In this session, we'll take a look at integration. The objective in this session are to examine the rules of integration. The first rule of integration we'll look at is the constant rule of integration. The constant rule of integration says that the integral for du is equal to u plus c. So let's take a look at some examples. In the first example, we're asked to find the integral for dx. So we'll use the formula, we'll simply change the variables. The integral of dx is equal to x plus the arbitrary constant. In the next example, we're asked to integrate 3 dx. The integral of 3 dx is 3x plus c. And in the last example, using the constant rule, we're asked to integrate negative 5 dx. And the integral of negative 5 dx is negative 5x plus c. The next rule we'll take a look at is the power rule. The power rule says that the integral of u raised to the power of n du is equal to 1 divided by the power plus 1, which is the n plus 1, times u raised to the n plus 1 power, plus the arbitrary constant. Let's take a look at some examples. In the first example, we're asked to integrate x squared dx. Notice that we're asked to integrate x, which is raised to the second power, so we'll use the power rule. The power rule states that we will integrate it as 1 divided by the power, which is 2 plus 1, times x raised to the power plus 1, plus the arbitrary constant. When we simplify, we have x cubed divided by 3 plus the arbitrary constant. Next, we're asked to integrate the integral of x dx. Notice that the understood power for x is 1, so we'll use the power rule. The power rule says that it's 1 divided by 1 plus 1 times x raised to the 1 plus 1 power plus the arbitrary constant. Once we simplify, we have x squared divided by 2 plus the arbitrary constant. Next, we're asked to find the integral for the square root of x dx. Recall that we can write the square root as the 1/2 power. So we'll write the square root of x as x raised to the 1/2 power. Now we'll apply the power rule, which gives us 1 divided by 1/2 plus 1 times x raised to the 1/2 plus 1 power plus the arbitrary constant. When we add 1/2 plus 1, we get 3/2, which simplifies to give us x to the 3/2 power divided by 3/2 plus the arbitrary constant. We can simplify further. 1 divided by 3/2 equals to 2/3 x to the 3/2 power plus the arbitrary constant. Lastly, we're asked to integrate 1 divided by x squared dx. We'll use the negative exponent rule, and we'll write 1 divided by x squared as x to the negative second power. Now we will apply the power rule. Once we simplify, we have negative 1 divided by x plus the arbitrary constant. Next, we have the constant multiple rule. The integral for k times u du is equal to k times the integral of u du, which means that we can take the constant and we can pull the constant in front of the integral operator. Let's take a look at some examples. In the first example, we're asked to integrate 5x dx. We'll use the constant multiple rule. We'll pull 5 in front of the integral operator. We now have 5 times the integral of x dx. We'll integrate x as x squared divided by 2. We'll multiply by 5, which gives us 5/2 x squared plus the arbitrary constant. Next, we're asked to integrate 3 divided by x cubed dx. So here we'll use the constant multiple rule as well as the negative exponent rule. We'll pull 3 in front of the integral operator, and we'll rewrite 1 divided by x cubed as x to the negative third power. We'll now integrate x to the negative third power, as negative x to the negative second power divided by 2. We'll multiply by 3, which simplifies to give us the result negative 3 divided by the quantity 2x squared plus the arbitrary constant. The sum and difference rule says that we can distribute the integral operator between sums and differences. Let's take a look at an example. In this example, we're asked to integrate 3x to the fifth power plus 7x squared plus 8 dx. We'll use the sum and difference rule, and we will distribute the integral operator, which means that we will integrate each term individually. First, we'll integrate 3x to the fifth dx plus the integral of 7x squared dx plus 8 dx. Next, we'll use the constant multiple rule. For the first term, we'll pull 3 in front of the integral operator, and we'll write that as 3 times the integral of x to the fifth dx. We'll pull 7 in front of the integral for the second term, so we have 7 times the integral of x squared dx. We'll also pull the constant in front of the integral in the third term, which leaves 8 times the integral of dx. Now we'll integrate the first term. We integrate x to the fifth power. That integrates as 1/6 x to the sixth power. For the second term, we'll integrate x squared as 1/3 x cubed. For the last term, we'll integrate dx, which gives us x, plus the arbitrary constant. And lastly, we'll simplify, which leaves us the result of 1/2 x to the sixth plus 7/3 x cubed plus 8x plus the arbitrary constant. Next, we'll look at the natural logarithm rule of integration, which says that the integral of 1 divided by u du is equal to the natural log of the absolute value of u plus the arbitrary constant. In this example, we'll integrate 4 plus 3x plus 2x to the fourth quantity divided by x dx. Before we integrate, we'll simplify by using the divide by monomial formula for algebra. So we'll treat the denominator as a denominator of every term in the numerator. Now we will distribute the integral operator and integrate. When we integrate 4 divided by x, we have 4 times the natural log of the absolute value of x. Next, we'll integrate 3, which gives us 3x. Lastly, we'll integrate 2x cubed, which gives us 1/2 x to the fourth plus the arbitrary constant. Lastly, we'll take a look at the exponential function of integration, and it states that e raised to the power of u du is equal to e to the u plus c. In this example, we're asked to integrate x squared minus e to the x plus 25 dx. We'll distribute the integral operator, and we'll integrate as 1/3 x cubed minus ex plus 25x plus the arbitrary constant. Thanks for watching.